it to the color of the normal, and it will become colorful, like that. Basically, if we have normal, if you understand what normal is, like each vertex, it's actually a vector, the direction where the face of the model is looking to. So we have RGB channels turned into XYZ turned into RGB. So red becomes an X, green becomes an Y, and blue becomes Z. So you can see, like, if you can draw like those axes, you can see why the colors are so made this way. And last thing, last magic I can show you, if I modify the position of a vertex by some random value, random algorithm, it can be like distorted in real time. So this small animation is done purely on the GPU side. So only thing which is CPU is doing here is getting the value of the time currently, which passed from the beginning of application run, passing to GPU, and all the transformations done by GPU. Just a small example of how GPU works. Another, maybe a little bit more complicated example, I will show you faster. Like that. The whole 3D scene is rendered purely by GPU code. So again, the only thing which is CPU calculating is the time value, how many seconds like passed from the beginning. And this is actually done by ray tracing, and this ball in the middle, it has real-time reflections from the outside environment. So some very complicated stuff can be done with GPU. GPU can also be used for just pure mathematics calculation. Due to its nature, GPU have only floating point data types for mathematical calculations. There are no integers on GPU, like not like on CPU, which is mostly made for integer value types. And the main difference also the GPU from CPU is that GPU processor has no jumps. For example, if in the code I will write some if statement, something, it will be executed anyway, if I write it false. So if you have like some conditional statement in the shader code, both parts will be executed and one part will be ignored if you don't need it. This makes writing GPU code a little bit tricky, but it allows GPUs to execute code in massive parallel. Like GPUs can have hundreds of cores or thousands of cores, not like CPUs, maybe 8 cores. So this is like a small introduction about what is GPU. I will stop that so it don't eat my processor. So after the small introduction, I will probably skip this slide. I will start from the why I'm starting to talk to you about this. The thing is that recently, past couple of years, the vendors, the producers of mobile devices, they started to claim that mobile GPUs are not now so powerful that they can produce the level of graphics which are the same as for gaming consoles. And I started to examine the question, is it true or not? There are a lot of discussions on the internet, whether they're lying or it's just marketing or is it true? And there are no like real good analysis for that. I haven't found at least. So I did analysis by myself. So let's start. The values which are used by vendors of producers of mobile phones, they use spec parameters. Flops are the amount of floating point operations which can be made by GPU processor during 1 second of time. So gigaflops are the billions of those operations. And so from this table, you can see that basically the vendors are right. So you can see that current modern mobile phones like Samsung Galaxy S8, which is a modern Android device, and iPhone 10, they already faster than previous generation of gaming consoles, and they're getting quite near the current generation. And if we extrapolate and consider the speed of growth of mobile hardware and gaming console hardware, mobile phones will overcome the speed of gaming consoles quite quickly, from the first glance at least. So why do we don't see any example of good mobile games with good graphics? These are just two games I have played recently. On the left is a game with the picture produced by modern GPU for PC, and on the right is a game rendered by mobile GPU. So they still look different. Let's start from this picture. When I say GPU, usually guys, especially who are hardcore gamers, they know that GPU is a big piece of hardware which is stuck inside your computer, and it produces a lot of noise and gets hot quite often. Are there any gamers in the room who play games? Some, but not a lot. Okay. Who have GTX 1080 at home? No, no one. Okay. In reality, mobile devices, the GPU is a small part of the chipset, which usually contains both CPU and GPU on one chip. And this is, I think this is from iPhone device, and I think this is chipset A7, if I'm not mistaken. But it doesn't matter. The thing is that they have CPU, GPU, and here on the bottom is the output to memory, and both processors have used the same output and input to the memory chip. So, horror number one: why we cannot use the features which GPUs provide to us, made by hardware vendors. So horror number one is the API, graphics API. Historically, we are using APIs which were developed somewhere in the 90s. It is OpenGL ES and DirectX, and the API was never designed to meet the hardware features of modern GPUs. For example, the multi-threading is not possible. In the 90s, multi-core CPUs were not popular and were like basically not in like home PCs somewhere. So APIs were designed to have a global state, so you cannot send execution tasks from CPU to GPU in from multiply cores, from multiply threads. This produces quite a big problem. For example, if you have ever played a game on your PC and you switch to see what is like task manager is doing, you could see that only one CPU core is loaded to 100% and all other cores are just resting. Probably you see this problem, and this is actually the reason. The pure API is the reason. I will actually show you how it works. I will start a demo right away just to show you examples in real time. So I have iPhone X, iPhone 6s, and I'm running the same demo I just showed you on my laptop. So it's the same fractal demo with like a lot of GPU load on this for the rendering. And from the profiler, we could see that GPU is loaded. All renders are utilized almost to 100%. GPU is loaded for like 33 milliseconds per frame. This is like full load. Don't look at this thing right now. This is lying. It's just a bug of the profiler. But I will show what this GPU is doing. You can see that we have basically one core which is loaded for rendering, on all others are like doing nothing. This one occasionally doing something, but basically only one core is loaded. So second problem with API is that all shader code, the shader which I just show you like this is a shader. All shader code shipped in your application as pure source. It is not compiled in the compilation time of your program. So all shader code is compiled in runtime when you run the program, basically on the device. And the compiler for the shader is a part of the GPU driver. So the problem is there are probably millions of different compilers, and not all of them are good quality. There are a lot of compilers who have some bugs, especially some syntax bugs. So you put some space between semicolon and like some compilers already failing. This is a huge problem. Basically, you cannot write single shader program, which is a little bit more complicated than simple, and be sure that it will be compiled by all devices the same way. API have poor memory management. When I showed you this picture, I told you that we have only one input-output to the memory for the CPU and GPU. Historically, all GPUs had a separate memory from your normal RAM, which is used by CPU. This is a good thing for GPU because it usually requires much faster memory. But in the mobile devices, probably there are not enough space for two memory chips, so usually those use the same one. Why we could use one chip in some better way than two chips? When a CPU makes, it's called a DrawCall to GPU, like it sends a task for execution, for rendering on the screen. It prepares a lot of information. For example, all the models which should be rendered, all the textures that should be rendered should be copied from the CPU memory to the GPU. And this is actually not required when you have the same memory. You could only send pointers to, okay, there I have texture, there I have model, but all the API actually doesn't allow it. We have the same memory chip, but we still must copy all the data from one part of the same memory to another just to make a render call, which is totally stupid. APIs don't have programmable blending. I will explain you what blending is. For example, in this example which we had with our sphere, oops, shader is not compiled. I think I have, yeah, I don't need this one. Never mind. Okay, I don't want to search for it right now for the bug. Okay, the blending is just how the pixels are rendered on the screen. If we have a sphere, currently all the pixels of the sphere, they replace the pixels which are rendered by the background shader. But if we could make blending more different, we could take a value of the pixel on which is currently in the frame buffer and add it to the pixels which are rendered by the sphere shader, or multiply, or any kind of other operation. The problem is that historically, all blending was done using hardware. So all blending modes were limited by a set of limited fixed functions because they were already pre-implemented on the hardware side. Maybe not all, but most of the modern GPUs, they implement blending on the program side. So basically you could write this as a formula, how to combine two colors of pixels, background and foreground together. But API doesn't allow it again. So this could be used for optimization of rendering. And we have no performance guarantees in the API. For example, if you execute a program, GPU driver could start doing something at very inappropriate moment. For example, new texture arrives in the memory with new format, and driver decides to recompile all the shaders it has in memory, and the whole application just hangs for 1 second, and then you receive those lags, visual lags in rendering. Ideally, it could be that the program could say to the driver, now I have a loading screen in front of my user, do all the necessary computations right now, but not later. It is not possible currently. That's why all the games and all the graphics are laggy, and graphics programmers cannot do anything about this. So, how can we fix those problems with APIs? Recently, basically, it was 2016, maybe you heard about it, the new generation of graphics API was announced. Vulkan have to replace the OpenGL, but we still have the war of the standards, and Microsoft and Apple, they released their own standards, and Metal was released by Apple as a replacement of OpenGL, and DirectX 12 didn't change the name, but basically it's totally new API, not backward compatible. So yeah, before we had 2 standards, now we have 3. So that things are not moving good direction in this sense. But new APIs, they have no global state, so rendering is possible from multiply threads using multiply cores of the CPU. It is possible to manage your memory, so it is possible to ask from the GPU driver whether we have a single memory chip or 2 memory chips, and then you use this the way you want to optimize your code. The good thing is that there are no differences now between mobile API and PC, for example. Before we had OpenGL and OpenGL ES for mobile phones, like a subset of the functionality of OpenGL. And yeah, standard war continues, as I said. Some people say that new APIs are overcomplicated. It is much harder to write a program using new API. But this is it's actually not so true. That when you have a team of programmers who work on some graphically intensive application, you only have a small part of the team which is working directly with graphics API, and all others are using some wrappers like written above it. So it's not a big problem. You have more problems only for a small part of the team. And most of the developers, they already use some open source wrappers or some engines like Unity, for example, who already make the implementations for you. The bad news is that WebGL, they stated that they are not going to use new standards. They're not going to move to Vulkan API exactly because of this problem. They said it's too complicated. They said that performance is not so critical for web applications, though there are some games written on WebGL working in browsers. So they are not aiming for high-end performance. They just need things to work. So WebGL will not move to Vulkan. And the main question is, this is horror, this is fixed for the horror, when we will get it. my estimation is that maybe in 10 years, graphics programmers could rely purely on new generation APIs. So there will be a lot of devices left for old APIs for many years to come, I think. So maybe in 10 years we will have a fix.
But 10 years ago, OpenGL was, DirectX was a thing too, you know.
Well, actually, DirectX is still a thing. For example, there are still most of the games, at least PC games, they are released only for Windows platform exclusive. They all use DirectX. For mobile devices, for sure, DirectX is not a thing anymore because no one have Windows phones. Who have Windows Phone? No one. That's what I thought. Or maybe there is one person who was just too shy to raise a hand. So yeah, Windows Phone is dead. No one cares about it. So Metal and Vulkan mostly. Horror number 2, heat. The problem is, yeah, again, I will come back to this slide. Devices which you have inside your PCs and consoles are really big pieces of hardware with effective ventilation and cooling. This thing doesn't have anything like this. All pieces are packed very tightly, and it relies, if it gets overheated, it relies on natural cooling of the foam, which is very poor actually. And every phone has a special mechanism to prevent burning. So if the phone would overheat like without any limitation, it will start to burn in your pocket or in your hand eventually. So every phone has a mechanism called throttling, which lowers the frequency of the GPU GPU and CPU to produce less heat and make a device cool. This is very good thing for the device, that it will not blow up or start burning literally, but it's very bad for the user. So the user has user experience gets much worse when throttling turns on. Everything starts to lag, FPS falls, and probably I can show you the throttling mechanism in work, maybe not yet. So I started our application maybe some minutes ago, but it still has 30 frames per second, so throttling not yet turned on. We will see maybe in the end of my presentation, we will see the example of throttling. So yeah, this problem makes device resources unreachable. Basically, as a graphics programmer, I cannot use 100% of resources which the vendors of GPU give me. And actually, GPU vendors, the producers of GPU are aware of that, and phone producers also. For example, I think I can already switch to the next slide. This one, yeah. I made a small test. Oh, sorry about Russian. Forgot to translate it. I made a small test with Galaxy S devices. I had 4 Galaxy S devices by Samsung, and I made a small test for it. I wanted to see how many vertices and how many pixels device is able to render in 20 milliseconds, for example. And I made a measure only after the device was working full power, fully loaded, CPU and GPU after 10 minutes. So Galaxy S4 had 500,000 vertices rendered in 20 milliseconds, very good. Galaxy S5 rendered almost 1 million of vertices. And both phones didn't overheat. So after 10 and even after 20 minutes, I checked, throttling did not switch on. And Galaxy S6 had only about 250,000 vertices rendered, because after 10 minutes it started to throttle. And the same for Galaxy S7. So basically, the last phone which was balanced natural heating and the power of the processor is Galaxy S5. Everything which comes after Galaxy S5 is actually bad. Don't buy those phones. Because yeah, I don't know how it happens inside Samsung. I could imagine that there is a team of engineers which come to their marketers and business guys and say, hey guys, we cannot do this phone, this powerful, it will overheat. And they say like, do we have something written about overheating in the phone specs, official phone specs? No. Put the most powerful GPU as you can inside. No one cares that it wouldn't actually work. So the problem is marketing, yeah, because those companies are selling phones and users, the consumers, they choose phones by the specs. So for sure you will choose to buy a phone which costs the same but has a faster GPU or more memory, faster CPU. You will buy this phone, but now no one actually tells you that no application could use this kind of power which is put inside your phone because of overheating, for example. So how to fix that? Well, the first idea, vendors should end the spec wars. So they must be honest with their consumers. They should say like, wait guys, we cannot make our next phone 2 times faster as we did last year because we have this problem. And now you just buy a new phone which is same as last one but a little bit more expensive. Maybe it won't work. I don't know how it will work. So this problem should be actually solved by marketers, not engineers. The reality is that if vendors will put lower-end chipsets inside their phones, graphic programmers like me could use it to make better level graphics than the current phones. And this trend actually is already seen in Apple. For example, last 3 phones, iPhone 7, 8 and X, didn't actually increase the speed of a processor. So the very first slide which I showed you, that's Galaxy S8 and iPhone are reaching the current generation of gaming consoles. iPhone X and 8 and 7, they all have about 350 gigaflops of speed. And they actually never advertise this. If you saw the last presentation from Apple, where they announced the iPhone X, iPhone 10, as always, they said, this is the best and the fastest phone we ever produced. They didn't say that actually GPU is the same. But they probably already heard iPhone 10 is the first phone which has GPU made by Apple customly. Before that, they always used GPUs designed by Imagination Technologies of Power VR series, so not their own. So iPhone 10 is the first one to use their own GPU, and there is a point why they did that. They wanted to consume less power. So basically the phone is, the GPU speed is the same, but it consumes less power. And this was advertised for consumers as a way to reduce the battery consumption. But in reality, I think they are aiming to get rid of overheating without adding some additional coolers to the device to still make the device smaller. So this was the point. But no one actually talks about it for some reason. And in the future, this problem probably will be solved. So other companies will also look at Apple, and this problem will probably be solved by making GPUs and processors consuming less power, so they will overheat much slower. And probably some cooling methods will be invented. I don't know, some new phone cases which radiate more heat, so it will cool faster. I don't know. Basically, right now we are near the singularity at this point. No one can predict what will be next year in this domain. So, so how do we avoid overheating? For example, in our project, we calculated that average playtime, average play session for our game is about 15 minutes, so on mobile phone. So we decided that we should guarantee that even on the toppest devices, which has unbalanced processors, we will guarantee to the consumer that we will have 30 frames per second for 15 minutes at least without overheating. So this way we will satisfy most of the customers, most of the players. And by making some experimentation, we ended up by using only about 60% of the device resources. So all those gigaflops, which are like advertised by marketers, for producers of the phones, cannot be used by us, only for 60%. And if you have an application who must have a play session with very intensive graphics rendering, more than 15 minutes, you will have to reduce the utilization of the processor even more and make basically your game or application look like, I don't know, outdated. So our number 3 are tools. Unfortunately, there are too many vendors who make GPUs for mobile devices on the market right now. And there are no standard way to connect, for example, profiler or some analytical tools to the GPU so to get some information. So every vendor creates its own tools. So we have different tools for Adreno Snapdragon, for ARM, for PowerVR, and so on. And hardware vendors are known to be the worst software developers. So all those software pieces which must be used by developers are absolutely awful. They crash, they don't connect to the phones, they don't give enough information. For example, Apple is considered to be one of the best vendors who make good tools for the profiling of GPUs and CPUs. Until now, we can see that integrated profiler in Xcode, it gives us the CPU consumption 0 milliseconds, which is, I know that it's not true, because when I go switch to CPU tab, it is fully loaded. At least one core is fully loaded. So this is it's lying. It's a bug of the profiler. And even this profiler has bugs. Like all of them have even worse bugs. Especially it's true when producers of mobile phones, they buy the design of the GPUs, for example, from third-party vendors, and they close all the holes which are used by the profilers. So there are some devices who cannot be profiled at all, especially some no-name Chinese devices. There are all ways to connect to the GPU are closed by the producer of the phone, of the device. And Apple actually is doing this. For example, Apple, as I already said, is using PowerVR in most of the phones except iPhone X, the first one without PowerVR. And all PowerVR tools are blocked by Apple. So you cannot use PowerVR official tools to profile GPUs on iPhones. Well, at least Apple makes its own tools for that. And there are more vendors like that. So will there be better tools in the future? Probably not. Probably there will be even more vendors for GPUs to make, because like Apple is already becoming a vendor for mobile GPUs, and it's like there are more and more coming to the market. So how to solve this problem? Probably one solution is to make your own tools. For example, big companies who like make big budget video games, they all make their own tools for profiling and so on. They directly communicate with vendors to make their own ways to communicate with hardware and so on. But if you're a small company who doesn't have resources for that, there are still some ways to optimize your work. For example, not so many people know that Google Chrome has a GPU profiler built in. So if you go, I will launch the Google Chrome. So if you go to Chrome tracing, it's a GPU profiler basically. Probably I can even show how it's working. Stop. Yep. So it splits out some information about GPU, which was consumed right now. Let it be consumed right now by Chrome. But the good thing about it, it has a function to load data and to save data. So, and the format of the data is very nicely documented. So if you're making your own application and you want something which will look like a GPU profiler to study the data, you can basically write a small script to spit out the information you need from your application to JSON file in the correct format, and then study the data using Chrome tracing. So this is one of the ways to optimize your work. So you don't have to create your own IDE for the profiler. And I think last version of Unity can do the same, but in different format. And the last horror number 4, is diversity. Probably not only unique for mobile phones, but still there are a lot of different devices on the market, hundreds of different chipsets. Probably thousands or maybe even millions of different combinations of different CPU, GPU, and memory. And some configurations are inadequate. For example, some phone producer installs a very powerful GPU in the phone, but CPU is not powerful enough to serve this GPU. Or GPU and CPU are both powerful, but not enough memory to use all the resources, and these kind of problems. This is especially true for no-name Chinese devices, and usually Android operating system. And to fight that, usually when graphics programmers which make games for PC, they allow gamer to choose manually the configuration of the graphics. But it doesn't work for mobile devices. So mobile gamers, they don't know anything about those algorithms, and they cannot choose them or settings, those like very advanced hardware, advanced graphic settings. They cannot choose it. So they have to be chosen automatically. We use the model of the device itself for iOS operating system, because there are not a lot of them, to make the graphic settings that choose automatically which post effects we're using or which like loading level we're using. And we use the model of the GPU chipset itself for iPhones. But you should remember, you can never satisfy everyone. There will always be some device your graphical application will like give inadequate settings, and it will be not good speed of rendering. And in conclusion, I might say that mobile devices did not reach the level of gaming consoles. So this was the question in the beginning. No, it is not possible to make games or graphic application with the same graphic quality as gaming consoles, and it wouldn't be in the nearest future, I think. So those marketers of mobile companies can, I don't know, shut up, something like that. The thing is that mobile devices will never be made for graphics. Mostly mobile devices are made for simple tasks like reading emails or browsing your Facebook, which doesn't require a lot of performance from the hardware side, from the graphics hardware side. And gaming will always be a bonus. And if you want to play games with good graphics, better buy yourself a gaming console or play on PC. Don't play on mobile phones. So, thanks. That's all.
Now we have a bit of time for questions, exactly 3 questions. I think we can fit in before we have a break and then proceed to the last talk. So first quick question by Dmitry.
Regarding this memory management, I remember from like beginning of 2000 something or 90s, there was a thing called direct memory access for graphic cards, and graphic cards could read from memory.
From a CPU memory, I mean.
From main memory. They usually, I think, copied that part of memory to their own video memory before processing, but it was possible back then, and it's like 17 years passed and mobiles could not get this working.
Maybe what the thing
Why?
maybe the thing you're talking about is was some kind of hack because it never been a part of official graphics API. So like to read directly the CPU memory, and even that's the reason of the problem. That even if you have the same memory for both devices, there is still no way to say to GPU, please take your data from this part of memory just because of API. Maybe you mean some hack which was developed by some smart guys in the 90s.
Don't remember.
But yeah, it's not really possible right now. I think it should be possible using Vulkan API, and only on device which have like combined memory. But I haven't tried it yet.
Okay, any more questions?
I can always ask questions.
Sure, go for it.
So Firefox is going to launch.
We want it?
No, I'm fine with it.
But here we get it.
So there were 2 days ago, I received a tweet, or there was a tweet in my feed that said that Firefox is going to launch some kind of a new web renderer, which is an engine that's using GPU a lot in a very nice way. It makes some of the rendering things very fast. And so when I read this article, they mentioned that they're pushing towards being able to render 4K images and displays and videos and all that stuff in a very fast way. So that's the direction that they're going to. So first question would be, have you done some work on being able to do these kind of graphics modeling games on browsers? Are you going to? And how do you see that kind of industry going? How far is that I'm going to play a very, very good 4K video game in my browser?
Okay, you are actually asking about 2 completely different things. One thing is that browser is using GPU to render HTML and CSS. This is one thing, and the browser can use GPU on very low level to do this. I think Chrome is already doing this long time ago, and I think Firefox too. I don't know what kind of news, maybe they will continue to make it expand the use of GPU or something like this, but they already do it. And the second thing you're asking, whether I can to make a web page with JavaScript to utilize GPU to render stuff directly in the browser window. These are actually totally different domains. One is like HTML, normal HTML rendering, and the second thing is like this HTML canvas using GPU. And as I said, it is already possible to make nice graphical applications using WebGL, which is JavaScript API for OpenGL ES. But guys from who make this WebGL standard, they said that the performance is not their main goal. so they are not switching to Vulkan as all other devices slowly. WebGL, like GPU graphics on the inside browser, will always stay some kind of like toy, like a bonus feature which is rarely used, I think.
Maybe after some years.
Maybe after some, do you think maybe they will switch to Vulkan when it will prove that it's like makes sense to use it? I don't know. But I think all browser applications will always be behind for rendering algorithms and so on after the standalone applications. That's for sure.
Okay, cool. Thank you. And last question, maybe? Anyone? All right. Yeah.
What are the challenges in bringing discontinuous gathering methods?
Can you take it as cube? Nice blue one.
Yeah. So what are the challenges in bringing the discontinuous gathering methods to GPU?
What are the challenges of bringing what?
Okay, I'll get back to you later.
Okay, I just didn't get it.
Speaking to the cube.
Okay. Discontinuous gathering methods?
Scattering. Sorry, I didn't get.
Discontinuous gathering methods.
Scattering.
Gathering. Aggregating.
Aggregating methods.
Yeah.
I didn't get it. Sorry.
Gathering method. Mathematician.
What kind of gathering?
Gathering methods.
Algorithm.
Algorithm methods.
Algorithm.
Gathering was a mathematician.
Sorry, let's talk about it
Yeah.
on when it will be break.
You guys can have a chat during the break time. So thank you, Philip. Thank you guys.